Oh my.
Hello, everyone. This is our presentation with drawing with an ABB robot. My name is David.
My name is Ryan.
Hi, I'm Taj.
I'm Lauren.
And I'm Brendan.
And today we'll be going over our experiences of using our skills and knowledge we gained in this class to draw with an ABB robot. So first, we're going to go over a summary of the prior projects that we needed in order to culminate in the final task. Second, we're going to go over how we programmed the robot to sort of actually draw the images themselves. Third, we're going to go over our findings in terms of the visual sense. We're going to go over and look at what we recorded and how the robot did these things through visual explanations. And finally, we're going to look at what we have learned and how we're going to move forward. And then we're going to also look at the social implications and how robotic painting will probably affect society in the future. Now I'll pass it on to Lauren.
Thanks, David. So over the semester, we worked on a number of projects that would finally culminate in us being able to draw our own image with the ABB robot. First, in order to get acquainted with the program, we started by drawing the university logo of the Block M. We were given the specifications for the logo, and from there, we simply had to create a program that would draw it using a pre-existing pen and pen holder that were provided for us. After that, we went on to design our own pen holder using our own pen of choice. This way, we couldn't just rely on something that had already been given to us. We had to actually engineer our own solutions for the problem. Once we had a 3D CAD model for the pen holder, we then had to turn it into reality by using the 3D printers in the fabrication studio at the university. Once we had the pen and pen holder, we created a program all on our own to create the Star Wars logo, and from there attached the pen to the robot and used it to draw the logo all on our own. I'm going to give it back to David now.
Thanks, Lauren. So the first project that we did was designing the Block M, which represents the U of M logo, obviously. And so in order to do that, we had to learn how to use RobotStudio and therefore write the code in order to design the Block M and any other future projects that we may have to use it for. And in addition, we were able to simulate the code in RobotStudio, so we were able to get sort of a final view of what it would look like. And in terms of the implementation, this was our first lab, and so we had to come into lab and actually upload the Block M code with the ABB robot, and the final result can be seen on the right. Now I'll pass it on to Taj.
Thank you, David. After project 1, we worked on project 2, which is basically designing a pen holder. We started off by brainstorming ideas for a utensil and a holder model. So we first had to figure out what we're going to use, and we picked a thick Sharpie. And for the holder, we have the prototype drawing on the left, and on the right is the CAD model that we generated. And then after that, we had to make a 2D drawing and then make a 3D CAD model. And then we're going to talk about the different aspects of designing the pen holder, which Brandon is going to explain thoroughly.
Thanks, Taj. So as you can see here, here's a computer-generated drawing for our pen holder from multiple angles. We'll start on the right in green where we can see the spring. This spring mechanism allows for elasticity in the pen holder so that when the robot presses up against something, it won't break with any sudden jerks or movements. Then in red, we see the flange adapter holes where you attach the pen holder to a different adapter that is then screwed into the robot. In blue, we see the M6 screw holes. These holes are used to tighten the pen holder to said adapter. Then in yellow or orange, we see the M3 screw holes that fasten the pen holder to the utensil, which again, as Taj mentioned, was a chisel tip Sharpie. Finally, in pink, we see the marker holes where said Sharpie would be placed into. With that, I will pass it on to Ryan to talk about projects 3 and 4.
Thanks, Brendan. So after we had our final design for our pen holder, we wanted to bring this to reality, which was the challenge of projects 3 and 4. So to do so, we created a G-code file using the CAD model with the CURA software, which you can see a rendering of on the picture on the left. After we had that, we then printed the pen holder using the Ultimaker 3D printer in the fabrication studio, which you can see in the middle image, the final printed part. After it was printed, we then had to remove all of the plastic supports that come with additive manufacturing, which is the final picture on the right. I'll now pass it on to Lauren to talk about the final culminating project of the semester.
Thanks, Ryan. All right, so for project 5, it was finally time for us to strike out on our own and try to draw the Star Wars logo. Unlike with the block M, we weren't given the dimensions outright, so we had to figure them out on our own. To do this, we printed out the logo of the desired size, and using a ruler, we by hand measured out the distance between several different points on the logo. You can see over on the right, you've got the measurements in millimeters just sort of sketched in on the printed part. From there, we could use the measurements to create the toolpath with the code from the RobotStudio. Unlike with the block M, where the pen just stayed in contact with the paper for the whole time, the Star Wars logo has individual blocks, as you can see between the T and the A, or the W and the other A. To manage that, that means that the pen had to come up and down between certain sections of programming. You can see that here in this third variable on the right, where the pen comes up 10 millimeters before going back down to 0. The pen has to stay up for 2 different code lines and not just for one. If it was only up for one, it would go up and then come back down at an angle. This could cause unpredictable behavior, which wouldn't do well for the reliability of the robot sketch. So it's easier if it just stays up in the air, moves to where it has to go, and then moves straight back down. Once we had the code, we were able to simulate it with the RobotStudio toolpath program. It's a lot easier to debug a program when you're only working with your own computer and not a very, very expensive robot that costs more than your own tuition. Once we were happy with the code that we had, we put it on a thumb drive and brought it into the university, where we attached the pen holder and uploaded the code. After some calibration, we were able to finally run the code, and as you can see on the right, it perfectly drew our Star Wars logo. Now going to pass it back over to Taj. You're muted.
Thank you, Lauren. Now we're gonna look at the final assembly visual for our project. On the left, we can see holder with the Sharpie inside it and the screws attached. And on the right, we have the holder attached to the robot drawing the Star Wars logo. Next slide, Lauren. And then for the assembly summary with the pen holder and the Sharpie, we use the screw holes to fasten to the utensil and as a holder to the flange adapter. Afterward, we use the adapter screw holes, then fasten it to the robot. And on the next slide, we can see the video of the robot's drawing. As you can see on the left side, it's drawing well and it's angled a bit. And we can see the different components that Brandon was explaining about the pen holder, about the flange and the suspension so it doesn't break the tip of the Sharpie. And then for our final drawing, you can see the Star Wars logo. And then I'm gonna hand it over to Ryan to talk about some of the issues that we encountered throughout the project.
Thanks, Taj. So throughout project 5, we encountered a few minor issues. First of which being properly fitting the pen holder that we designed to the flange adapter. So when we designed this using CAD, we didn't have the exact dimensions of the flange adapter, so we kind of had to estimate it. So to fix this, when we actually had to execute the drawing, we ended up having to wrap tape around the adapter, which you may or may not be able to see in the picture at the bottom. This was done to increase the circumference of the flange adapter so that we were able to have a snug fit on it using our holder. So next was fitting the screws to secure the pen. It was a time-consuming process that we might improve in the future, which I'll actually talk about on the next slide as well. And then finally it was a time-consuming process removing all the supports after the 3D printing. Next slide, please. So going forward, how would we improve the pen holder? Well, first off, one of the problems was the chisel tip Sharpie not securely fitting inside of the holder. This was done because we didn't know the exact dimensions and cross-sectional area of the chisel tip Sharpie when we did our CAD design. And it's very likely that inevitably over time, it would become loose due to the screws loosening. So to fix this, the solution our group came up with was obviously to measure the marker beforehand to be able to have the exact sizes in the CAD design. The next problem was fitting the pen holder to the flange was rather difficult, also time consuming. So the solution is to, now that we know the exact dimensions of the flange adapter as well, we can work this into our CAD design. So that it doesn't have to be fitted to it using tape like we originally did. We'll have the exact dimensions. And then finally, another problem was that the spring on the pen holder didn't provide a lot of elasticity, and that if there was a lot more pressure, it could have significantly bent or even broken our pen holder. So to fix this, when designing future pen holders, we could increase the elasticity by adding another layer to the spring in our design. Okay, now I'm going to pass it on to Brendan.
Thanks, Ryan. So for this project, we had a lot of deliverables and it spanned a couple months. So we had to make sure we were staying on task for the entire semester. So as we mentioned, the 5 different projects that we have, we split them up into 5 different sections on this calendar here. We then looked at each project guidelines that we had for major deliverables seen in the tasks side on the left. And we divided them down and blocked off different sections. And we decided who was going to do them. In this case, we said each person was going to work on everything equally and when we wanted this to be done by, seen in the filled in blocks with the dates above. Initially, each of these blocks were black. And once we completed a given task, we colored them to green. As you can see, we completed each task. And if we didn't complete something on time, we'd have to work as a team to get it done better and efficiently in a timely manner. Eventually, this all worked out. We were able to finish each deliverable by the time it was due. Now I'll talk about the societal impact of robotic painting. So after completing this project, we wanted to think what robotic painting and drawing with industrial robots could do for society in the future. So if we were to scale up the process, it would introduce a lot more people to the art industry. Robotic painting makes for cheaper art because obviously it takes a long time for an artist to create a certain piece of art. So if this process was industrialized, a lot more people would be able to be introduced to the industry simply because of the fact that the art produced would be a lot cheaper. One of the drawbacks to this, however, is that art could lose its cultural significance and what it truly means to people. As a result of this, it'll force a lot of human artists into obsolescence, potentially. With that, I'll pass it over to Taj about how we could explore this societal impact.
Thank you, Brandon. And then now we're going to talk about the societal impact, the study plan, and we're going to go over the purpose, method, hypothesis, experiment, and specification, and the conclusion. So the purpose of this experiment or the study plan in this case is to predict the impact of robotic painting will have on our society. And then to study this plan, we're going to conduct a quantitative study on consumers to determine the effect a decreased price will have on their tendency to purchase art, since robotic painting will make art much cheaper and it will produces at a faster rate. So it will have less art meaning, but like more products in the long terms, and the price will go down and it will allow normal consumer to buy more art. And then our hypothesis for this project is to predict that we'll to find some correlation between lower price and willingness to purchase a given piece of art that was made by an industrial robot compared to human, because human takes a long time to make art, as Brandon mentioned before. And for our experiment, we're gonna do a large cross-sectional survey amongst adult ages 30 to 60 and medium to high income household, because those are the people that spends a lot of money on consumer goods, and art is considered some type of consumer goods. And then we're gonna see who identifies themselves as interested in buying art and who isn't. And then for the specification of this project, we're gonna take art that has been created by hand and ask individual how they see it different from the art that was created by robots, and see their willingness to purchase the different art based on the different price point for this. And in conclusion, We're going to compare the differences in willingness to buy art that was created by a robot in comparison to human, and see how much more art that people buy or how much less due to robots being introduced, and the value of art. And then I'm going to pass it on to David for the conclusion, who's going to summarize everything that we talked about in this presentation.
Thanks, Taj. So throughout this entire semester, we have culminated ourselves in learning and given ourselves sort of a good experience with practical engineering. And what we exactly did was, first, we successfully designed and 3D printed a 2-part elastic pen holder to be attached to the industrial robot, in addition to a chisel tip Sharpie to act as sort of a module extension. Second, we used the RobotStudio software to program a toolpath for both the Star Wars logo and the UMISH logo, so that it would be able to actually draw those two things. And finally, we now have experience with CAD design, toolpath programming, 3D printing, and effectively writing technical reports, all of which will no doubt be a huge part for engineering careers in the future. And so moving forward, so to our engineering careers, we will build upon this foundation that we've established here by designing models with CAD software, possibly RobotStudio, and if we ever decide to go into the 3D printing sector, possibly CURA as well, as we further our knowledge of engineering and enter the workforce as practical engineers. May the force be with you.
Thank
Thank
you,
you.
everyone.
Thanks.